We will complete our modeling with the HEC-RAS, which we did before with the GIS, and I exported in the tutorial number 4. I exported to the HEC-RAS. So today we will be working with some how can modeling this river by use the Manning equation and define this flow as a steady state flow. First, sorry, we have to go to the geometric data and try to import it. First, we already have this one here. So okay, and open this one, then import the GIS data, this one. Okay, there is 2 units, the US unit and SI unit. I'll take the metric unit. This is the details shown here for the backlines and the depth of river. These things we did before in the GIS with the HEC-RAS. Anything we did there and exported here, it's showing in this table. So like GIS, cut lines, stations, elevation data, and the reach length. Also the bank stations. So finish. It's showing the direction also for the river. It's coming from the upstream to downstream. So we have to add the Manning equation. We don't know actually the specification of this area. I mean which type of a ground. So there is like earth or concrete. So I'll be assuming as a constant things like 0.035. It's also the same. Sorry. So then, okay. We have to try to save this one in the same location. So geometry. Then close this one. By the way, if you have like structure, as I said before, the lecture 3 or 2, you have structure like culvert or a bridge, we can use this, you know, these tools to define this structure. It is necessary to do it. So anyway, I will skip this one because I don't have any structure in my area. Here is showing the peak flow for this river. We can get this data for the flow from the USGS website. It's showing there some informations for all the rivers, I mean the world, so we can get some input data from there. Anyway, I can assuming the peak flow is 600, just assumption, but we need to get this data from the from USGS or from any office which you're interested to do some this modeling. So this is the showing the depth. There is 3 types of depth, like YN, which is normal depth, and Y naught, which is any depth, and the third thing is called the critical depth. So I'll assuming the normal depth is 0.15. This is in downstream and upstream. Then okay. Then data. We have to save this one also. So save flow data tutorial. Flow data. And close this one also. If you have unsteady state, we have to guess data like the flow changing with time. I mean, this also sometimes this flow be like increasing, so we need to add all of these like flow series showing here. This is the showing here. This is the elevations for each point. We have to try to add these things and add the, and this is showing here the simulation time. Next maybe lecture I will or next tutorial I will try to build the new river, to build new model for the river, and make this one simulation with time and see what's going on with this one and how it's changing this one with the time. I mean, how can increasing to the how can flood it by use this method, which is unsteady state flow. As I said, now our example is a steady state, so I will skip this one. Here, if you have like sedimentation on the tank, on the reservoir, or in the on the river, we can find it. So showing here there is some error message, and the error, in the back lines, is like less than or equal to 0. We have to fix it. This is the typical section of the river showing here. You see this points here is not correct point. We have to make it exactly on the boundary of river. So this point is showing in the inside of river. So this is another one is like wrong point. Also this one, same issue. So I have to fix this one up to get the new simulation. This is the river showing here. After we run this model, we will get the graph showing the peak flow with time. So